Today's lesson is on rational equations and their word problems. A rational equation is any equation with one or more rational expressions in them. And to remind you what that is, that's any expression with a fraction. X is in the numerator and or denominator. Here are some examples. Notice that each one of them have fractions in their equations, and x is on the numerator and or denominator. The steps to solve a rational equation are 1. Factor all denominators. 2. Find the least common denominator, or LCD, of all of the denominators. Then you're going to multiply every term by that LCD. There should be no denominators left. Now, the reason we're allowed to do this step right here, multiply every term by the LCD, is because we have an equal sign, because I'm multiplying the left and the right hand side of the equation by some value which I choose to be the LCD. So it's because of the multiplicative property of equality, that's why we're allowed to do that. We didn't show you this method back when we were adding or subtracting rational expressions because it wouldn't have worked because it didn't have an equal sign. Okay? Step 4. Solve the resulting equations. Some resulting equations may be linear and some may be quadratic. You don't really know which one's which, so you're just going to have to solve whichever type that pops up. Number 5. Check for extraneous solutions. Now, we just talked about in the last lesson that we have extraneous solutions are any solution that is not valid due to the process of solving. So what you need to do is substitute your answers into the equation. Now, this one does have a shortcut, whereas the last lesson to check for extraneous solutions, you didn't have a shortcut. The only thing that would make one of these values that you get for an answer extraneous or extra or invalid is if the solution makes the denominator equal to 0. That would be the only bad case. So then if that happens, just throw out your solution because dividing by 0 makes the expression undefined. Then keep all the solutions that do not create zeros in the denominator. So that's a little bit of a shortcut. You don't actually have to solve the left and the right and work it all out, which is good because this has rational expressions in them, which are fractions, and that takes a little bit longer to check with fractions. So step 1 says to factor the denominator, but we don't need any denominators to be factored, but I could break them down a little bit so that it would help me find my LCD for the next step. So 6 is 2 times 3. 8, that's 4 times 2. 2 times 2 times 2, or 2 cubed x. And then 12 is 4 times 3, or 2 times 2 times 3, or 2 squared times 3. Okay, so when I'm looking for my LCD of all of the denominators, I need to look and find each unique factor. So I have a 2, and I have a 3, and I have an x. So these are the 3 unique factors, and we're raising it to the highest exponent. So with the 2's, the highest exponent I have is 3, so I need at least 3 2's in my denominator. My highest exponent of 3, it looks like just 1. Okay, and then x. So when I multiply 2 cubed, which is 8, times 3, I get 24x. Now, some of you may have been able to look at 6, 8, and 12 and just know that the LCD between those 3 numbers is 24, and that's great. And then don't forget your x as well. And if you can do that, by all means do it that way. You don't have to break it all down if you don't have to. So step 3 tells us to multiply every single numerator by the LCD. So I'm going to come up here and multiply every single term's numerator by the LCD. By doing this, first of all, don't be lazy. Don't try to not write this all out. And very, very, very important that you write it all out. In doing this, it should divide out nicely. All denominators should go away. So let's reduce. On the first fraction, the 6 and the 24 reduce to 4. The x and the x divide out, and you're just left with 7 times 4. On the second fraction, the 8 and the 24 reduce to 3, and the x divide out to 1, so you're just left with 5 times 3. On the third fraction, on the other side of the equals, the 12 and the 24 divide out, you get 2. Now, the x doesn't divide out on this one, so we're going to have 13 times 2x. Okay, so then when I add like terms on the left-hand side, 28 minus 15, that's 13. And then I'm going to solve. Notice that this is linear, not quadratic. That's really good news for me. All I have to do is divide by whatever's in front of the x. Please be careful and don't just divide by the smaller number. You're dividing by who's ever in front of x to make that go away. 13/26 reduces to a half. So my potential answer is a half. I say a potential because I need to check my work. So I'm going to come up here and check my work by plugging it in. Every time I see an x, I'm going to plug in a half. So that gets me 7 over 6 times a half, that's 3. 5 over 8 times a half, that's 4. Is supposedly equal to, I put the question mark over it because I'm not sure, 13/12. Now, the shortcut here is any denominator 0? Well, no. When I plugged in a half, I didn't make any of the denominators 0. So guess what? I am good, and I don't have to worry about trying to make sure that the left side equals the right side. All I really care about is that when I plug in my x value, I don't make the denominator 0. Because in these problems, that's the only time you're ever going to get extraneous solutions. So there's no point to actually checking. I will go ahead and finish this just one time, just so you see how you could possibly check it for accuracy. But you don't really need to check for accuracy here. All I really care about is that you're checking for extraneous. And we've already checked to make sure that doesn't make any denominator 0. So I'm going to get an LCD of 12. 28/12 minus 15/12 is supposedly equal to 13/12. Well, yep, it does. So yes, this is not only not extraneous, it's also correct. I didn't make any mistakes. On this next problem, I need to find the LCD. Now, notice that there's no real factoring to be done here, and even the 12s, because the two numbers are the same, I just know that I need to have a 12. And I also need to have an x, and x is being raised to the highest power is 2. So 12x squared looks like my least common denominator. I'm taking 12 to the highest exponent, which is 1, and x to the highest exponent, which is 2. So 12x squared is my LCD. So the next step is to multiply every single numerator by the 12x squared. Please don't be lazy. Write this all out on every single numerator. Don't think, oh, I know it's going to be there. I'll just not have to write it and I'll do it right. That's when you make mistakes. Please don't do that. So on this first fraction, the x squareds divide out, and you're just left with 1 times 12. On the second fraction, the 12s divide out, and one of the x's divide out, and you're just left with 1x. On the third fraction, the 12 and the 12 divide out, and you're left with 1 times x squared. Okay, now look at this problem. This has a squared in it. The last problem, when we worked it all out, just was linear. It didn't have any x squareds. But this one does have an x squared. Just like we said in the steps above, it doesn't really matter if it's linear or quadratic. You know how to solve both. So I'm just going to move all of my terms to one side of the equals. And if this equals 0 on the front half, you don't like that, you can always just equal it to 0 on the back half. You don't really need to do that, but some students really don't like having it in the front, which is fine if you want to just move it. So I'm looking for two numbers to multiply to 12 and add to invisible 1. That's 4 and 3. So that's plus 4 minus 3. I set each of those factors equal to 0 to solve. So I'm getting x is -4 and +3. Those are my two potential answers. potential because I have to check them. Now, let's check only the shortcut way. If I plug -4 into all of the denominators, really all I care about is the denominators. Is this equal to 0? Well, -4 squared, no, that's 16. Is 12 times -4 0? No, that's -48. And is 12 0? No. So I know I'm going to keep that one. Let's try the next one. Checking x equals +3. 1 over 3 squared, that's not 0. 1 over 12 times 3, that's not 0 on the bottom either. Equals 1 over 12, that's not 0 on the bottom, so that is also a good solution that's not extraneous.